Okay, so let's get started. Today, we are going to have a look at one of the latest additions in Sirius Web with the table representation. I'll introduce myself quickly. My name is Stéphane Bégaudeau. I'm working at Obeo. I'm a software architect working on Sirius Web, and I've been contributing to the Sirius ecosystem for the past 15 years on various projects, such as Axeleo, If, or Sirius Desktop. And over the past few years, I've worked exclusively on Sirius Web. So let's get started with Sirius Web. Sirius Web is a platform to build domain-specific tooling. It is a web application based on popular frameworks such as Spring Boot or React. It gives you the ability to create and parameterize a modeling workbench for your end users. Sirius Web provides the Explorer on the left to let you navigate in your data, the detailed view on the right, among other views, to see the details of the selected object, and in the center, you have the representation currently opened. Here, a diagram. So Sirius Web is an open source project of the Eclipse Foundation. It gives you access to a web-based modeling workbench. First of all, you have to define your concept. Then you tell Sirius Web how to view them and manipulate them, and then you can start working. So let's see how it works. First, you have access to this user interface to create your domain-specific tool by defining your business domain. Here, I have a very small subset of all the entities visible in the previous screenshot. I can define my entity, the attributes, and the relation between those entities. I can do all that without leaving my web browsers. In my real example, I'm using way more concepts than the 6 entities I've just showed you. Here is a glimpse of all those concepts. For those who are familiar with Sirius Desktop or Eclipse EMF, you can bring your regular eCore model containing all your concepts in Sirius Web without issues. It's especially useful for those who want to move from a desktop-based tooling to a web-based one. After that definition of your concept, you can now start working on the tooling. By the way, you can work iteratively. You don't have to define all the concepts first to start working on the tooling. Here, I'm creating a diagram description to let my end user interact with my concept using a graphical approach. My diagram here will be created on my concept of project, as we can see it from the domain type in the green text field on the right. Inside of my diagram, I want to create a node for each application concerns and configure all their properties. Among all the properties, there's one key property that needs to be configured, the semantic candidates expression. It is used to tell Sirius Web which object in your data should be considered for this graphical element, here a node. If you return 5 objects from this expression, we will create 5 nodes in your diagrams. Since the root of my diagram is a project, we will use this application concerns reference to find all the application concerns inside of my data. After a couple of minutes, we have defined our concept and our tooling, and we now have a custom workbench to start working on our ideas. You can see that I'm missing some icons in the Explorer. My diagram is clearly missing some features, and I just have a name as the property of my service. But this is the first domain-specific tooling that I've created in minutes. If you take more time to customize it, both your concept and your tooling, you can end up with something like this, with everything in which everything has been tailored to my needs. Of course, since you can configure everything, you can create something completely different for another domain. Sirius Web can become the perfect tool to keep track of your Pokemon if you want. Sirius Web comes with various representations such as diagrams, forms, trees, Gantt, deck, portal, and of course table. I've mostly shown you the diagram, but the Explorer is a tree-based representation and the detailed view on the right is a form-based one. Both could be configured just like the diagram. Now, let's talk about tables, the latest representation supported in Sirius Web. We have introduced support for table late last year, in November or December, if I recall correctly, and worked on adding new features over the past 6 months. So this is what a table looks like inside of Sirius Web. The integration of tables is based on the framework Material React Table underneath. For my example, I will display and manipulate a set of tasks representing real Sirius Web tasks that we are currently working on or that we have done recently. There's the number of the task, which you could use to see the real task on GitHub, its name. I've made up some random priority and cost, and whether or not the task has been completed. With Sirius Web Tables, you can manipulate a large set of data, but it works exactly the same way as other representation. We don't make any hypothesis on the shape of your concept. You can parameterize it with a description, and it's synchronized with your data and updated in real time. There are 3 ways to create a table description, just like other kind of representation description. You have the View DSL in the browser, the View Builder API in Java, or the low-level programmatic API in Java. You can see a glimpse of all 3 approaches here. The View DSL in the web browser is nice if you just have access to the web browser, you don't have access to the server, or if your end user want to extend the application by creating new kind of representation. Both of the other approaches are using Java source code. We would recommend the View Builder API, and this is what we are using on major projects because it gives you the same level of abstraction as you can have in the web browser, but without having to manage low-level details that you can have in the programmatic API. So let's have a look at the first table, its description, and how we can play with it. So for that, I've created a studio in which I've defined a definition for a table. It will be created on a project. I've specified its name. I have 4 columns, descriptions. So one column description could be used to generate multiple columns. Here I've made a simple table in which one column description will create just one column. Here, the first column for the name has an initial width because I want it to be a bit bigger than the other columns. It can be resizable, contrary to the other columns. I've also have a definition for my row with a semantic candidate expression that I will detail a bit later. I'm using a specific service to compute the label of the header. So I can register Java services inside of my server and use them later inside of my expressions. So here I've created a small service to compute this header. I will show you how it behaves in a minute. And I have 4 cells definition. I could create just one and reuse it for all my columns, but I want to configure some details a bit later. So this name cell will be for the column for the name. It will display the name, and for that, it will rely on a label widget. So if we go in my example, so inside of my example, I have one project with some tasks here that I've created already. And I will create one instance of my table. So you can see the table in action. You can see here the label header that is computed from my Java service. It's just finding the number of the task from its name. You can see that the name column is a bit bigger, that I can resize it. And I have other columns that I can't resize. I can export all my data in a CSV file if I want, and I can open it, not in Microsoft Edge, sorry, but in Microsoft Excel here. So if you want to export your data to share it with other people, it's fairly easy to do. We can also change the order of the column thanks to drag and drop. We could also hide some column, and you could control all the columns that are hidden or visible. You can also pin a column to prevent it from being moved. And these are the basic options that you have inside of the table. So now let's modify a bit our definition. So if I go back to my table here, I could enable, for example, the stripped row option fairly easily. I could change the pagination options. So for example, I want to have 10, 15, or 20 objects per page, and I want it to be 15 by default. I can also change the icon for each row with a custom expression. So I can use here, I want to use the type of the object. So each object has a specific icon, and I want to display this. And if I go back to my example, I made a mistake with the icon. I'll just check to fix it. Icons, yes, missing a slash. So if I go back, yeah, my icons are good. So you can see I have striped rows, one gray, one white. You can see that the pagination options have changed, and now it's 15 rows by default. And you see how we can iterate between the description of the representation and the table to very easily change some setting and see the result in a couple of seconds. Inside of our table, we have support for pagination. It was one of the key concerns of this implementation of table inside of Sirius Web. Server-side pagination is compulsory for performance. We just can't send everything from the backend to the front end. It would be too slow. On top of that, we need to ensure that we are not navigating on every single object from the model if that's not necessary. If you have hundreds of thousands of objects in your model, and if your end user are viewing the last page of your table, you don't want to navigate on everything to render this last page. For that, we have supercharged the semantic candidates expression to give specifier the ability to write very efficient queries. First, the result of the semantic candidates expression is expected to return a paginated data instead of a collection. This paginated data will give us additional information. For example, it will tell us if there is a previous page or a next page. Okay, let's consider that this small set of objects is your model with the objects connected in a very specific way. You want to navigate this tree by following its topology depth first. Keep in mind, there may be hundreds of thousands of objects in a real tree. Now, your end user was on the third page of your table. They want to display the fourth page. There are 5 rows per page. So what should be displayed? Well, the first page would have these 5 objects. This would be the second page. This would be the third page. So the fourth page, what we want, would be these objects. If we put an index on each object, you can see in which order we would navigate inside of this tree. So how do we give you, as specifiers, the ability to perform this navigation efficiently? Well, the first approach we considered was using a simple page-based approach. It's quite easy to manipulate. We would give you access to an offset and a limit with 5 objects per page. If we want a fourth page, it's quite easy to understand that we want the object with the index between 16 and 20. If you have a list, it's very easy to do. But if you don't, of course, you could create an index of all the objects and keep in mind which position they have. But it would be very complex for an arbitrary tree, and you would probably need multiple index for various table representation that you need to create. Here, if you want to find the node 16 to 20, it's a bit more difficult without navigating on every single element until you have the 16th one. On massive amount of data, that would create significant performance issues, which is why we have adopted another approach based on cursor-based pagination. Cursor-based pagination is nothing new. It has been adopted by major products like the GraphQL API of Facebook or GitHub. You can also find support for cursor-based pagination in Spring Data, for example. In Sirius Web, it gives you the ability to write performant tables for large datasets. Thanks to this approach, you won't have to navigate on all the objects or keep a complex index. We will give you a specific set of variables that you will have to use. Let's see how it behaves. Asking for the fourth page is not the right question in this case. With cursor-based pagination, the question would be different. The end user was displaying the third page. You want the next page, so we will give you access to a cursor and ask instead to give us the 5 next rows after this cursor. You know how to navigate inside of your data. You know what you want to display in this table. So if you want to find the 5 elements after the cursor, you just have to navigate on those specific 5 elements. If you don't have a massive amount of data, you can use the Java service named toPaginated_data with the specific variables, cursor, direction, size, and we will compute this pagination for you. In this example that I'm using in the table description, it's not efficient. My expression here will navigate the entire model, but it's a small model, so it does not matter. All contents that we can see in the expression will literally navigate on the entire tree of model objects. If you know what you're doing, you can write a more efficient expression, but with this approach, you will still have to return all the elements of the table. By having access to the cursor and cursor-specific variables, you can, for very large use cases, write a custom iterator to navigate the tree and just to navigate the relevant objects. So if we give you access to the cursor, we give you access to the cursor and tell you that we need the 5 next element. With this kind of approach, you can just use this iterator to navigate on 5 objects, regardless of the size of your model. With tables in Sirius Web, you can not only see the data, but you can, of course, edit the data. We are providing various kind of widget, text field, checkbox, select. You can write also your custom widget to extend the table support in Sirius Web. So let's have a look at the edition of the data. So right now we can't edit anything. We'll go back to the studio, and this time we will use another table definition. The first thing I will do is that I will change what we are viewing. We were having a table displaying the task. I want to display instead the iteration, the milestone of the project. If I go back to see what it looks like, sorry, wrong project. So now if I'm creating here, you can see that I see the milestone. The milestone have a set of tasks that are planned to be done during this specific iteration. But there's no concept of done on an iteration in the current example. So this attribute does not make sense. And on top of that, I also want to see the task for each milestone. So I can go back to my studio and change the expression used to compute the element displayed inside of my table. So for one iteration, I want to display 2 things. So first, I'll take my iteration, and I want to display the iteration plus all the tasks of this iteration. I also want to have the same icon as in the previous example. And if we go back to the table, you can see now, if I display more objects, but I'm displaying the milestone, and I'm also displaying the task just after the milestone. But this cell is still useless for me. Our support for tables has a low coupling between the concept of column, row, and cell to give you the ability to both reuse one column description to create multiple columns, or one cell description to create multiple cells, but also to create empty areas in your tables. So here, for example, I don't want this cell everywhere. Sorry, I want this cell only if my object is a task. Otherwise, it's not useful. I will also add some actions on my table. For example, a new task action to very easily add a new task inside of a milestone. I will use an icon for this new task. So here I want specifically the icon of task. And I can define the behavior for this action. I want this action to be only available on iteration. I don't want to create a new subtask. So for my behavior, I can use this declarative way to define the behavior inside of my table. So first, I will keep my current object, the iteration, in a variable. I will move to its parent folder. Inside of the parent folder, I will create a task. I will put it inside of the folder and I will name it new task. And once I've done it, I will go back on my iteration and I will this time set the list of tasks of my iteration to be all the current tasks, including the new task. I will also update this behavior here. Okay, I've done it already. So I've changed the widget here from a regular label that I've used here to have a text field. So the text field will use my current object and change its name. And for the done cell, I will use a checkbox instead and update the value of done. So if I go back to my table, let's have a look. So now this support for done is absent for iteration. I don't want it, so I can create these empty cells for my table. If I edit the property of this object, you can see that everything is synchronized and updated in real time in other representation. I can change the done status and everything is updated. If I try to create a new task, it will create a new task and affect it to this iteration here. So I can edit my data fairly easily without having to leave my table. Our support for table also has support for filtering. So you can filter the content of the table both by using a global filter on the top right corner of the table and by using column filters. So you can see on the screenshot that each column can have a specific filter. You can also select between 3 widgets to filter a column. Text that you can see on the name column here. You can also have a range. You could see it on the cost column with a min and a max, and also a slider to define the range with a slider widget. You can also sort the content of the table. You could sort on one column or on multiple columns. You could sort in one way or the other way quite easily. So let's have a look at these options. So I'll go back to my studio, and now I will update this example to add support for filtering and for sorting. So I will first activate the support for sorting on my name column, and I will consider the filter and the sort order on my semantic candidate expression. So here I have created two services to filter the content that I will display in the table thanks to what the end user has typed in the browser, and also to sort what I will return thanks to the colon sort variable, which contain the details of what the end user is asking us to do. You could see here both Java services that I've written to do this fairly easily. Doing this kind of things in Java makes it quite easy to test your code and also to reuse these kind of expressions of services, in multiple representations. So if we go back to our table, it should be possible now to filter the content of the table thanks to the global filter here. And we can also sort the content of the table using this widget. Both of these properties, along with others like the width of the column and things like that, are persisted inside of the representation. So if I close it and if I create another one right here, and this time I will look for appearance, and let's order it too. I could, as the end user, create specific tables with some specific filters and sort settings, which will always be synchronized with my data to have a look at a very specific part of my data. So if I go back to the previous table, you can see that the filter is persisted. You could share the URL with someone else and they would see the same thing as you do. And if we go back to the other one, this one is specific for the appearance task, while the other one was for the relaying task. We also have access to sub-rows if you want to collapse and expand some rows in your table. It could be useful when your elements have some sort of relation, parent, children, from one to the other. To sum up, with tables, you can display data in tabular view. You can edit them with a dedicated widget, including custom widget. We have support with for pagination, and it has been specifically tailored for large use cases. You can, of course, edit the data with some actions on the rows. You could export it to a CSV file. You can filter, sort the data. You can create sub-rows. And some more details. I've skipped some minor options. You could also display a table within a form representation. Here, on the details view on the right, you could see that I have a small table in this form. It does not support all the features of a regular table representation yet, but we are working on that. But if you want to display a small table inside of a form, it works today. So to conclude, inside of Sirius Web, we have a large set of representation like diagram, deck, Gantt, portal, and table. all those representations have been covered by webinars. We also have form and trees that we have not discussed yet. If you want to find the previous webinar on diagrams or Gantt deck and portal, you can find them on YouTube. All those features can be synchronized on the same data. So what you're seeing in your table can be displayed simultaneously in a diagram or in a Gantt representation. So here are the links of those YouTube webinars. You can also find additional videos, a product tour, roadmap, and tons of content on our other products. If you want to know more about the latest versions of Sirius Web, you can go on the obeosoft.com blog. Sirius Web 2025.6 has been released this week. The blog post for the announcement is not yet published, but it should be published in a couple of days. You can find there all the latest features that have been integrated inside of Sirius Web. If you want to know more about Sirius Web and follow the details of the project, you can have a look at our official website or our GitHub repository. We are performing a major release every 2 months. If you want to get started, you can go on GitHub, download Sirius Web, and just run it. But if you, just like I did to show the demo today, you can also integrate parts of Sirius Web in your own application. You could integrate just the support for table or diagrams inside an existing application. You can also build an application on top of Sirius Web in which you would configure everything. We are also providing Obeo Enterprise for Sirius, a proprietary extension to Sirius Web application, which gives access to additional features such as authentication, authorization, webhooks, and more. Thank you for watching. And if you have any question, don't hesitate. So the first question, can you import CSV data back into the table? Assume this would create new concept instances, correct? We don't provide generic support to import the CSV data back into the table because we don't know the transformation that has been made from the raw data to create the table. As you've seen, I've used some expressions to parameterize the table, and we don't know how to create the inverse of those expressions. But in Sirius Web, it would be fairly easy to have an import feature to import CSV files. Right now, you could import one model as an XMI file, which is a kind of XML, or you could download the entire project and have your model as JSON objects. But importing and exporting data in Sirius Web, it's not very difficult, and using extending one of our regular import mechanism would work for any kind of representation. And it would create new instance, but you would control the way data are imported inside of the project. So you could create new concept, you could update new concept, you could do anything you want. Multiple downstream projects have customized things like that. The second question, what kind of support is there for right-click contextual action? In tables, I don't think that anything is triggered thanks to the right-click. You could think of triggering some sort of context menu on a right-click on a cell. But the only way to open such contextual menu is by clicking on the button at the end of each row. So you can't open it with a right click today. Is it possible to navigate between a concept displayed in a table and its corresponding diagram representation? If you select something in a table, it will be selected in the workbench. If this concept is displayed in various diagrams, you would not be able to, in one click, jump to this diagram. But if the concept is containing diagrams, you could fairly easily navigate from one representation to another. You can't yet navigate from the content of a table to the content of a diagram. Regarding the import from CSV, I'm thinking about possibly mapping field in CSV to field in the concept tables. Yes, you could create a mapping like that and have a specific strategy to import your CSV files, but you would just contribute something like that for the whole project. Actually, the menu where we have this download CSV file is extensible. You can add additional action. So you could add an upload button here and just open the dialog to drag and drop CSV file. And if you have a specific mapping between the CSV file and your table, you could create something like that as an extension in your product. Another question, did you already use this table representation in any public workbench? This table representation is used in multiple examples that we have inside of Sirius Web. I suspect that the downstream project Papyrus Web, which is a project based on Sirius Web inside of the Eclipse Foundation, may be using tables already, but I'm not sure that there are other popular projects using tables for the moment. One new question, is it possible to sort several columns? Yes, you can sort multiple columns. It would just create a more complex Java service than the one I've displayed. But yes, you could order the name column alphabetically and then the done column or another column using another sort order. Yeah. And if that's it for everyone, thank you for attending this presentation and see you next time, probably for form or tree representation.